welcome to another episode of the Value Engineering Experts as we continue to explore the phenomenon of E5. Today we have Robert Higgins back, a panel of experts, and some interesting questions for Robert to clarify. If you're enjoying these podcasts, please press subscribe at the bottom, YouTube or your Apple presentation. And we look forward to many years associated with E5. Recently, we decided to share Canada with Michael Mcleod, who was on an earlier podcast with Robert and was quite impressed as well with what it looks to be 1,000-year life concrete. Now, we're not going to be around to test it. We are certainly interested in ending rehab. So without further ado, we'll have our guests commence the podcast shortly.
I had some discussions with some concrete experts recently, and I got really irritated by it. I realized that just how deep the ignorance of concrete really goes, and most knowledge of concrete is by rote. It's not by actual knowledge, where they learn from other people and they continue these, I call them old wives' tales and myths, because a lot of it has nothing to do with how concrete actually performs. A lot of it is because we don't understand the history. The history of concrete, as far as we're concerned, and as far as the effectiveness of E5, really starts back 1950s. 1950s is pretty much the last time we had really good concrete. That concrete, when it was placed, there's concrete roads and bridges and other structures that were placed back in the 50s that looked like they were put up, 5 years ago. Whereas we have other concrete structures that were placed 10 years ago, they look like they're 50 years old. There's a quality difference, and a lot of it has to do with what we did with cement and concrete and what we didn't do to adjust. Back in the 50s, we had a lot more cement in the concrete. The reason why we had more cement is because it wasn't ground as fine. When they found they could grind the cement finer and get higher early strengths, they started reducing the amount of cement they put in concrete to get a targeted value. And the targeted value was established at 3,000 PSI and 4,000 PSI. 3,000 PSI concrete, if you could take it to the 1950s and put it side by side with concrete being placed in 1985, the concrete placed in 1985 is 500% more permeable to water than the concrete placed in 1950 at 3,000 PSI. There's that big of a difference.
And how do you summarize that again, Robert? You're saying it has to do with the fineness of the cement?
Yeah, because what they did is they reduced the cement content from 1950 to 1985 by about 34% because they could get 3,000 PSI at 28 days. So the targeted value was the PSI, not the amount of cement in it. And the other issues they had is when they put more cement in it, it heated up too much and caused cracking because a finer cement produces more heat because a fine particle, you have a huge surface area as compared to mass. And that is one of the primary elements that's involved with all of this that's been ignored in concrete technology. The finers, every time you have a finer material of any sort, you have a massive surface area as compared to mass. That's why if you take a big block of ice and you chip it up into small pieces, it melts much faster. The reason why it melts much faster is because there's a large surface contact area rather than mass to surface area. And it's gotten worse because as of 2002, we had another element that began to be applied to concrete, and it kind of flew under the radar because it was not being addressed by the concrete or the cement industry. And by 2019, the beginning of 2019, they came out with the announcement that low alkali cement will no longer be offered. Well, it won't be offered because there isn't any. All cement now is more alkaline than it used to be. These alkaline particles have been reintroduced because of EPA standards. The EPA standards requires recovery of what's called cement kiln dust. Cement kiln dust is a very fine material. There we go again with a very fine material. It's been added to cement, and it's made cement upwards of 400% more alkaline than it used to be. The alkalinity in cement reduces its ability to hang on to water. as far as allowing it to be available to cement. Because one of the other things that this concrete and the cement industry is not dealing with is the higher the alkalinity, the lower the relative humidity will be in the concrete. And this gets exacerbated as cement forms, it starts reacting with water, it absorbs water into the cement compound and becomes a permanent part. It's chemically bound. This reduces the moisture content inside the concrete, which in turn increases the alkalinity of the moisture in the concrete, which reduces the available relative humidity. For example, if you take water at a 0 alkalinity, you can get to 100% relative humidity. If you add sodium hydroxide and it gets to 20% concentration, the relative humidity, even if it's completely saturated, the relative humidity in the concrete is reduced to 78%. That is too low to produce cement. It gets to 30%, it gets to 63% relative humidity, and that's way too low. And what that does, it actually dehydrates and helps prevent the cement particle from absorbing any moisture, even if it's rehydrated. We've been seeing this gradually happening, and we even see this in lab reports. And I really liked it. A gentleman by the name of Dr. Hollinger decided to test concrete in the field and also in the lab. Well, in the lab, which to me was more important as far as what he was trying to show, was he actually took concrete that would break at 4,000 PSI under compressive value. What is not shown in these compressive value tests is the surface can be much weaker, but it still breaks at 4,000. So when they did a lab study where they did the 4,000 PSI concrete, if they sliced off the top inch of the concrete, that top inch of the concrete was 1,200 PSI weaker than the remainder of the concrete. And then if they did water cure it, even at 7 days, it was still 800 PSI weaker than the remainder of the concrete. Well, if curing worked, that should not happen. This is precisely why I'm so excited about the E5, because the E5 prevents this from happening, because it doesn't allow the concrete to dry out. It doesn't allow the alkalinity to build in that manner. And it gets worse if it's heated. If you take concrete, for example, at 28 days, standard cement back in the prior to conforming to the EPA standards, even back then, it would take at 73 degrees Fahrenheit was the maximum temperature you could have and still have your 28-day strength and your anticipated 100% strength gain at 1 year. When you get to 90 degrees, for example, you get 150% of your 28-day design strength, but then you reduce the concrete value at 1 year down to 82%. So there's a trade-off. Everybody's concentrating on the 28-day. Nobody is paying any attention whatsoever to the long-term strength or even at 1 year. So we're wondering why we're getting worse concrete. That's why we're getting worse concrete. The only way to reverse this trend right now is to use E5. I'm absolutely convinced of it because the other pozzolans are also moisture demanding. They add to the problem, they don't help it because you're dealing with a dry material, tiny particle, it has no water in it. It takes water from the mix. That's what I want to start with. So that's why I want to kick this thing off with.
Can you comment on fly ash? And like when you mentioned the 1950s, when did we start using fly ash and how has fly ash affected this equation?
Fly ash has actually been used probably since the 1950s. There was no value in it. But as cement started getting more and more expensive, fly ash was also a disposal problem because it was part of the coal manufacturing process, was all waste product. So they started incorporating fly ash in, instead of it going to the landfills, they started using it in concrete and they found some benefit to it. However, not all fly ash is consistent, and they actually divided it into basically a type F and a type C fly ash, where one was very alkaline and the other one was acceptably low in alkalinity. The one that's high alkalinity caused problems. Surprise. Well, so does cement kiln dust. It's funny, they've recognized that with the fly ash, but they're not recognizing what the cement kiln dust. And here's another thing. I think the concrete industry is intentionally misleading people because one of the new test they want to start doing for concrete floors is to incorporate ASTM E96. And I told them, I said, well, you can't do that because the maximum thickness of the sampling allowed in E96 is 1.75 inches. I said, yeah, well, what we're going to do is we're going to core the concrete and cut the first 1.75 inches and test that. I said, why are you doing that? I said, what you're doing is it's a worse test and kind of a modification of the calcium chloride test because it's dependent upon the free evaporation of moisture. And when I started thinking about it, I think this is intentional because if concrete is more alkaline, if you do an E96 on a really permeable concrete that's high in alkalinity, it won't pick up moisture. It will tell you that there's no moisture coming out, even though it's captured because it's captured by the alkalinity. That test is a trick. And I'll be damned if I don't think that's done intentionally, because that's going to throw people off thinking that the adhesives are wrong, the coatings are wrong, this is wrong, that's wrong, and when it's actually a deficiency in the concrete. This is terrible. It's gotten really bad. And I kind of want to keep it between us because something like this is something for our quiver, but I don't want to go after the concrete industry because the cascading effect will hurt the same people we're trying to help. I just want you to know this as a knowledge base. If you check out everything I told you, you'll find out it's 100% accurate.
It's not like it's deliberate, is it, Robert? I mean, the idea, it's just the way things progressed. We've got a lot of dedicated salesmen and lab people that, do you think they're going to take it personally, or?
I think they're puppet masters in here, and there's others that think they understand it and they're being told they understand it. So they just come along with it. It's kind of like the emperor's new clothes. They're convinced the emperor has new clothes. And they're saying, well, this is a good way to test it. And Juan, who's a guy I have a lot of respect for, although that's been diminished somewhat since then, I won't mention his name, but he insisted the E96 is a good test. I said, it is not. If you have high alkalinity, so I'm going to give you an example. I did some consulting work for this concrete that was basically completely waterproof. It had no excess water, but it was really expensive. And I told him, I said, what you're doing is ridiculous because it's too expensive, but it's a good product. He said, yeah, but we can't get it specified because the architects want the RH values to be 85% or lower. I said, why? I said, because he said that's excess moisture. I said, RH has nothing to do with excess moisture. That's water vapor. That's not even the moisture in concrete. That's just water vapor of whatever the pore space holds. I said, yeah, but that's what's required. I said, let's trick the test here. So what I have them do is take a nitrate, add that to the concrete. It's basically an inert salt, doesn't do anything. They've been using it for decades and upon decades in museums because you can put a certain amount of that in with these critical displays and keep the humidity from spiking and from changing. So depending how much you put in, we played around with it till we got it to where it was between 80 and 85% relative humidity in the concrete, and we just put it in. Now, was the moisture content any different in the concrete? No. All we did is add a little bit of salt, reduced it from 95 down to 85. It's the exact same amount of water. That's what the E96 is showing you. So if you got a salty alkaline piece of concrete, it's going to measure lower. So say, oh, that's good for the E96. No, it's tricking the test. These guys are being manipulated. It is terrible concrete. It shouldn't be used, but it is being used. And one of the things when I've talked to people in the field, they notice the concrete's curling a lot more, and a lot of the curling is not settling down the way it used to. I said, yeah, that's because it's permanently dehydrated. You cannot recover the damage you experienced on the front end anymore. It's not possible with a higher alkaline cement. Most of it is concentrated to the first 3/4 of an inch to 1 inch of the concrete surface. The rest of the concrete doesn't undergo the same type of problem, which is why it curls. Because if it's drying out, it moves to where the drying side is and curls upwards. So we're going to see a lot of that. We're going to see a lot of cracking, and we're going to see a lot of coating and flooring failures. And the $3 billion problem it was this last year is going to look like a walk in the park. Moisture-related claims for flooring materials in 2021 from very good sources hit at or it was slightly more than the $3 billion. If you put E5 in that concrete, they will have no moisture issues.
Can I ask you a question in a little different kind of a format?
Yeah.
So you've touched on such very, very good points, and I'm 100% in agreement with you. One of the terminology that I use is anaerobic concrete. Have you ever used the term anaerobic?
Yeah. Yeah.
So can you relate that term anaerobic to what you're saying?
I have to think about that, but that may not be a bad idea because we just need a degree of separation. It's like when I was talking to people about dew point. See, one of the things that the salts do that's different is we've been looking at dew point and condensation. I said, well, Bob, dew point's always at 100% relative humidity. He said, not ionic dew point. Please look that up. And we should incorporate ionic dew point into our vernacular. And it should be a part of every one of our presentations. Ionic dew point is a really good example is the sodium chloride they use in the calibration solution. They put that in there because what it does, it keeps the relative humidity at 75%. No matter how much water is in there, it always measures 75% relative humidity. However, the ionic dew point of sodium chloride is 74% relative humidity. So if you take salt, sprinkle it on the concrete, and the relative humidity is below 74%, nothing happens. But if it gets more humid, it turns, let's say, 85% relative humidity, the whole area gets wet. But if you test the relative humidity unchanged, it's still at 75% if you measure in and below the salt. It does not register above that. That is its ionic dew point. It's well below 100%. Sodium hydroxide, even more so. The ionic dew point of sodium hydroxide is right about 8 to 9% relative humidity. So as it gets more concentrated, that's how it stays. As it gets more diluted, then it starts coming back up again. But like I was telling you, if at 20%, it'll bring the relative humidity down to 70%, no matter how much water's in there. So if you're ponding water on concrete and you think that's curing the concrete, but the relative humidity inside the concrete, 78%, there's no cement formation. It stopped, especially if it's heated up. If you heat it up, what happens, the calcium hydroxide, the Portlandite that's being developed as the cement hydration goes, it becomes insoluble. So it actually puts a crust around the cement particle and prevents it from absorbing water. We're doing the double whammy of alkalinity and heat. Prior to the cement being more alkaline, the ideal temperature was actually 55 degrees Fahrenheit for concrete curing. It didn't achieve the 28-day strengths. It gives you 125% of your 1 year targeted value. Gives you really good, strong concrete. So it shows you how we're going in the wrong direction. I mean, in everything we're doing, we're going in the wrong direction.
Can we use, I had a question, Rory put this question forward. Can nano silica and silicates both be used as admixtures?
Nano silica can, silicate absolutely not. If you use it as an admixture, the only reason why it's ever been used as an admixture is in shotcrete to help reduce rebound, because it thickens the shotcrete mixture. But what it does, it makes the shotcrete more permeable and less dense. So it can't waterproof. It does just the opposite. And all the information that's out there keeps proving it. I even had a recent study sent to me from BASF where they added a sodium silicate to concrete, and it made the concrete 12% more permeable, which is consistent with what it does with shotcrete.
That's interesting, Mike, because we have our friends in Alberta that push the silicates.
Stop doing that. In fact, if you want to make your concrete irreparable, that's a good way to do it, because you can't fix that. That's like adding calcium chloride to the mix. It's probably even worse.
Yeah, the product that Martin's alluding to is, the idea is when you add it into the concrete mix in the truck, it's doing the same description that you were talking about earlier about, the calcium hydroxide, breaking down that shell, allowing more of the cement to be hydrated, therefore increasing your strength, workability, all those things, right?
Yeah, but unfortunately for them, they're about 7 days too early.
Well, why is that? What's that?
Calcium hydroxide, about 75 to 80% of it forms over a period of a week, and almost 100% of it forms over the course of 28 days.
Okay.
So there is no calcium hydroxide to react with. When you add as an admixture, it reacts with things you don't want it to react with because it doesn't wait around for the calcium hydroxide.
Okay.
If there's fly ash in there, it'll react with, it'll thicken up the concrete, it'll ruin the mix. If there's any kind of limestone in there, it'll ruin the mix. It reacts, sodium silicate reacts with almost everything. If you look up sodium silicate patents for say like fire bricks and things of that nature, you'll see how it's mixed with fly ash and other materials and then heated to form these fire bricks because it makes its own type of concrete. So it doesn't wait around, it thickens it up. Thickening the concrete is exactly the opposite of what you want it to do. You want it to thin the concrete out and make it more spreadable. That's why slump tests are so important. If you're pouring concrete, there's no slump, you can't place it. That's what happens with a shotcrete, but that's also why it sticks to the wall. It's to the wall because it's thick. It's sticky. It wants to stick to the wall and not bounce back off. And the difference between do you know what the difference between shotcrete and regular concrete is? Basically the aggregate and the form of delivery. Chemically, it's exactly the same thing.
Does E5 have a product that's used as an additive for the kind of qualities that we were talking about earlier, as far as increased strength and workability, durability, that type of thing?
Yeah, in fact, that's what got me so excited because everything about it qualifies as a pozzolan. What a pozzolan is, it's a material that you add to concrete that has no cementing properties of its own, which is extremely important because you don't want cementing properties that can interrupt or take over a reaction that's undesirable. So you want a pozzolan. Now, the difference between the nano colloidal silicas is part of this particle is water. It has water in it, which is perfect because it doesn't add to the water cement ratio. But what it does, it has all these tiny particles in there. And again, there's this enormous surface area as compared to mass. So as the cement consumes the water, this keeps replacing it. So rather than reducing the amount of moisture that's available to the cement, this keeps and continues to replace it. And since calcium hydroxide forms between 75 and 80% over the first week, and then the rest of the way over the course of 28 days, that's the anticipated timeline that you're going to have with that, where you get a really, really dense surface that you would not get and you can't get if you don't put that in there. Because the dry pozzolans are water demanding. They don't give water back to the concrete mix. That is really the fundamental difference. And I mean, it's that simple. We don't have to go into all the complicated stuff. That is really the simple difference.
And are people using the E5? What's the name of that product?
They call it liquid fly ash.
Liquid fly ash. Oh boy,
Yeah.
Isn't that interesting?
I know. I would prefer you call it liquid pozzolan because that's
Yeah.
more accurate what it is. But he's a concrete guy, so he wants to get something that people are familiar with.
Right.
Because technically speaking, it acts like a fly ash, but that, as far as I'm concerned, that's a very undersold way of presenting it because it's pretty amazing.
Yeah, that sounds great. In our experience, fly ash, like I try to keep fly ash out as much as I can on floors because I call it spongecrete when it's got fly ash in it.
Well, if you don't cure it properly, see, that's where it gets worse. And see, what you're experiencing is exactly what I've been telling people. Now that we have more alkaline cement, fly ash is going to contribute to the problem rather than help alleviate it. Back in the day when we didn't have alkaline cement, if you added fly ash and you cured the concrete properly in cooler weather, you got really good concrete. If you put fly ash in hot concrete, you're screwed. You're going to get really bad surfaces and there's really nothing you can do to stop it.
Yeah.
It's going to make it worse.
I agree, totally.
And it's not the fault of the fly ash, it's the fault of the conditions that it's being presented with now. Now, if you took 1950s concrete, put fly ash in it, it's perfectly okay. But since 2019, nope. 2019 is the big cutoff, and that's the benchmark we should use for history of concrete from now on, because there's a new cement that's being introduced, and expected to be very commonly used, is called type 1L. After doing research on that, that would make the concrete also more challenging to work with when it's hot. But the irony is, because it is more calcium rich, you're probably going to get exceptionally good concrete with E5 in the concrete mixture. But you'll probably have to adjust the amount you put in, because with a higher calcium content, I would put in more E5 to exploit the differences in calcium content and turn that all into usable cement. I mean, you're probably looking at granite density, or at least approaching it. It'll be really dense. So for E5, 1L is great. If you're not using it, you're gonna have all kinds of issues, especially in the summer. Martin, you got any questions? David, you got any questions?
The one for us up here in Ontario, and me being out in a rural area, I'm just curious to see when they put in the farms and that they're putting in liquid manure tanks and stuff like that. It's all concrete. Would the E5 be an acceptable additive to add to the concrete, so to stop the liquid manure from seeping into the ground and then getting into the groundwater?
Yeah, it would make the concrete exceptionally dense, especially the critical surface. It's really important. I would probably finish with their catalyst, because if you're dealing with manure, what you don't want it to do is get in and start reacting with the calcium in the concrete, because that forms all kinds of chemical reactions that actually cause damage to the concrete. It doesn't just leach, it actually causes physical damage to the concrete.
So the E5 added to the concrete, and then what would you suggest, capping it, if you will, or sealing it off to prevent that?
Yeah, they have this product called E5 Catalyst. So they spray that on, and the concrete I've seen where they put that on is extremely dense. There's almost no absorption into the surface at all. There's no chemically active calcium left over, which is the biggest deal.
So that the catalyst would go on in the mix itself, or does it go on as a spray on of application?
A spray on application after you place the concrete.
Okay. And then would there be anything that we want to put in the concrete with E5 as well?
Not really. Whatever they recommend, I think they have a plasticizer, but I wouldn't recommend anything past that. I'm a big believer in reducing the amount of moving parts.
Great. Okay, great.
Hey, this is Rory. I just wanted to say the catalyst would be sprayed on during the finishing process, and
Okay,
then you
good.
actually
Thank you.
finish it in with the power truck.
Okay,
Yeah.
good. 'Cause I haven't
And it
experienced
doesn't
it
take
yet, so.
much.
Yeah.
Yeah.
Is that right?
Yeah, just a very, very light application. It's a very light application of catalyst that you spray on during the finishing process, and you spray
Okay.
it on the concrete, and then you finish it in with the power trowels, and then you walk away. You're done. That's it.
Excellent.
Okay, awesome. Thanks, Roy.
I'm a neophyte with this. All I've really concentrated on is the chemical reactions in the concrete. The E5, that's what I got so excited about. So I'm just learning about their other products, such as the catalyst.
Right. I have one more too. I'm involved with a GC that does a lot of hockey arenas. So pouring their slabs for the hockey arenas and that.
Yeah.
Same thing there. What would you suggest would be a best one to put that in, just so we can eliminate a lot of the cracking and curling that would occur during that cure period?
Exactly. The E5 and the catalyst, I would go with both of those, because I saw some of their videos and it was really amazing where they had one with and without the E5, and you could see where the concrete was pulling away from the wall as it was curling without the E5 in it, and the E5 remained snug against the wall.
Okay, so that'd be the same one, the E5 catalyst?
The E5 and the E5 catalyst, yes.
Okay.
If you want a really dense surface now, or a warehouse or something, you may or may not have to do that, but it just depends on what kind of quality concrete they want. If they want the top end of the concrete, I would go with both of them.
And then the last one I have is up here. They involved in a lot of precast panels or tilt-up walls, if you, same idea. Ideally for doing that, and also to waterproof those panels at the same time.
Okay. Now, I'd love to see if we could get to the precasters, because precasting concrete, if you ever notice, is extremely permeable on the surface. If you throw water on it, the water disappears.
Yeah.
See, and I'm going to use as another example, the concrete industry doesn't know what the hell it's doing. When they first came up with the idea of precast and post-tension concrete, the idea was to steam cure the concrete because that would make a perfect cure for the concrete because it keeps it, accelerates the set, accelerates the cure, and just keep the concrete 100% wet. By all means, this should do it. Now, if they understood concrete, they would know that that would have interfered with the calcium hydroxide because calcium hydroxide, as it's being produced by the cement, becomes less and less soluble as it gets hotter. It's at most soluble right at the point of freezing water. That's when it's most soluble. So when you heat it up, it no longer wants to take on water. So that's why the surfaces of precast concrete, post-tension concrete, are so permeable. Now, I think they added E5 to that. A lot of that could be reversed.
So I have one company that I'm very close to up here that's a precast guy. I'm wondering if there's Martin, could we maybe do a test with these guys if I could get them to go along with that, but maybe we could do a test with it just to see if it does help them out for their materials, and even to the point of maybe waterproofing or tightening it up if that's the case.
What you're saying, Robert, is that wondering about is if it wasn't moist cured or if it was just D5, you'd probably have a better product than the way precast is traditionally done.
Yes. And also, if the precast starts using the 1L, it'll be really interesting because they may end up, if they put the E5 in there, with better concrete than if they just use a standard type 1. That's theoretical. One of the things, because I've been involved a lot with roads and bridges. I've spent a lot of time in waterproofing tunnels and things of that nature. And one of the things we always notice, if you did a misting of water rather than a water ponding, we always got a more efficient curing and a much tighter concrete surface. Well, one of the reasons for that is when you mist water onto the surface and you don't have an actual layer of water, you're exploiting a natural phenomenon that's known as evaporative cooling. When I was teaching these classes, the way I would show the students is I'd have them get their hands wet. Now, when you get your hands wet, you'll feel cool down, but then it goes back to normal room temperature. However, when you blow on them, your hand, wow, it gets a lot cooler. Then I'll have them do that with acetone and their hands feel like they're freezing. Why is it cold? Because it's evaporating faster. Evaporative cooling effect actually reduces the temperature, which if you look at the nanoparticles of the colloidal silica with a huge surface area with the water, you're actually basically mimicking a misting of the water, and you're actually able to cool the concrete inside the concrete that isn't possible with ponding water or water alone. You can't do it. And you certainly can't do it with another pozzolane.
If I could arrange a meeting or of such, or a Zoom meeting, would you and Robert be open to discussing possibility of using the E5 with this precast company?
Absolutely.
Yeah, Dave, I've got some stock, and the best thing to do is try it for sure.
Yeah.
I think we're saying that we'd be very confident in what's going to happen.
Yes.
Okay. All right. I'll see what I can put together.
And I'll tell you what, if they can move towards the 1L, they will get all kinds of bonus points from your government too, because that's showing a lower carbon footprint. So with the E5 is a lower carbon footprint, along with the 1L, they'll get all kinds of bonus points for that. They could get a competitive advantage doing that.
David, have you ever heard of the 1L before? Is that a term that you're familiar with? I really just saw it with Robert.
Yeah,
no, 1L cements. We don't know what he's using.
Okay. The concrete industry is really going to be pushing the 1L, and there's several manufacturers, and I think there's even one up in Canada that's making it now. So I don't think they'll have a supply issue, because basically it's just replacing some of the cement with limestone. The limestone gives it a higher calcium content, so that's what I was saying with the E5. We may have to batch it with a little bit more E5 to compensate for the additional calcium. But oh my God, I mean, the potential density is pretty exciting. Would normally be a worse concrete to have, will end up being better.
Mm-hmm. Okay, I'll see what I can put together.
Okay. What do you think, Rory? You there?
Yeah, I'm here. I just had to unmute. Yeah, Robert, the 1Ls have also caused some problems for the finishers, in my experience, because it's ground so fine strength to be comparable to the type 1-2s. So
Gotcha.
your blade fineness, 1L is approaching 500 blade fineness, and it's
We're getting every other word, Rory. Sorry. Not even.
with the water cement rate.
What you're saying, Robert, is that the 1L cements are becoming very commonplace.
Yeah, and there's a push towards it because they're looking for a lower carbon footprint. Because cement produces more carbon dioxide than anything else that's man-made. And concrete is the second most common used material only to water worldwide. So there's going to be a big promotion, a big push towards that. So let's go with the flow. But thankfully, the flow appears to be working in our favor.
So to summarize, you're saying with the 1L,
Hey,
you'll actually end up with a better result. In other words,
E5.
more waterproof potential using the 1L.
Yeah, I actually think so. And so I went through the technical data sheets as well as their safety data sheets. And when I saw the high calcium content of each one of these, I thought, oh my God, this is awesome. Because here's something else for the E5 to react with, but having that much more in there, I don't know how much adjustment they'll need to do. That's going to be it's not a big challenge, but it is a challenge.
Can you guys hear me now?
Yes.
What I was saying real quick is the blade fineness, the blade fineness of the new 1Ls is approaching 500 blade. So it's so fine that it's got an increased water demand, and they have not compensated by adding more water like they should be. So it's extremely thirsty. When we adding the E5 into it, it's actually allowing them to hold the water in there, the precious amount of water that they have in there. It's holding it in there so they can get a decent finish on it. And without the E5, it's extremely prone to excessive plastic shrinkage cracking and crusting of the surface. So E5 is solving that in the field.
Yeah, and I believe that. And what I'd love to see is what the compressive values are at 1 year, because I got a feeling the difference is going to be outstanding. And I'd like to see a study done where they actually start slicing the top inch of the concrete and start analyzing that differently, especially in hotter weather. People are going to be shocked at the difference between the strength of the body of the concrete versus the surface. That will finally show them just how permeable and weak the surface of the concrete is. And that's why I don't like the ASTM E96, because that exploits the weakness to make it look like it's a benefit rather than a detrimental effect that they now have with the concrete. And that just angers me. I don't know if that's done through ignorance or it's done on purpose. I think it's a combination of both. And I think we need to head this off at the pass.
Yeah, so I think we're already indirectly, we've answered all your questions or asked all your questions. We could go back to the idea of flooring. You know, what type of concrete mix do you recommend for flooring?
Well, the concrete mix design is typically a 0.45 water cement ratio is what I recommend. And I would stick to that. Although with E5, they may be able to get away with something even as high as a 0.50. And I think that would benefit. And then if they go with say like a 1L, I think they're going to have some floors that the only thing you have to worry about is how dense the surface is. And you got to really watch dew point at time of installation, because that's one of the things I found with dense concrete is when you go to install a floor, it takes very little moisture on the surface to create a bond issue with your adhesive and your flooring material. So you just walk around with a Tremix meter, you put that on there, make sure it's not getting wet. Use an infrared thermometer, a digital hygrometer, which gives you a real-time readout of temperature and relative humidity. And if you're within 10 degrees of dew point, you need to bring in a fan and blow the concrete dry before you get started. I've done this. I did this over in San Diego with a lot of success. And I actually did one job over the phone where they had this 3-story building. XL Brands was the adhesive company, and I was doing some consulting work for them. And the consultant there told them that they needed to moisture mitigate this 300,000 square feet, which was going to add another $1 million to the project and delay the project by over a month. And I told them that was a waste of money, because I could tell by the tests that they were sending me had nothing to do with moisture originating from the concrete. And I took issue with the expert on the job site, and I had him tied up in knots in about 2 minutes. You're not paying any attention to the stack effect. And he didn't know what the stack effect was. So the stack effect is being evidenced by the moisture test you're conducting, because at ground level, what should be higher is the lowest moisture readings you're getting. And it's a 0.45 water cement ratio, and it's fairly predictable with what you're getting. The second floor is a little bit higher than the first floor, and the third floor is even higher than the second floor. It's called the stack effect. Warm air rises, it gets humid, the concrete's cooler air, so it absorbs the moisture. So what I had them do was just go in there, blow air across it, took the Tramex meter. Once it dropped 0.7%, they started installing the floor, and perfect, it went perfectly. They didn't have to mitigate, and they just followed the fan. And they were going to add another $1 million to that to fix a problem that didn't need to be fixed. That just shows you how off the flooring and the concrete industry is, because they think, well, that's originating from the concrete. It's originating from underneath. Most everything that we're taught is that moisture moves from the bottom to the top of the concrete, and that is absolute bullshit. That is absolute bullshit. They do not understand the concept of diffusion. They talk about it, but they don't understand it. I've done this in a little science class, and you can do this tabletop if you want to really have fun with people. This one's slower, so you can't do this for a real-time demonstration, but I would take 2 cylinders and would connect it with a pipe. There'd be a valve. The one cylinder would have salt in it, very salty water, and the other one's clean. Now, you test them. This one's salty, this one's clean. You turn the valve and give it about a week, and they even out almost completely. The water didn't move anywhere. That's what they think. There's this soil contamination underneath the slab, and it magically moves up to the surface, bringing all this stuff with it. No, it doesn't. It's the water providing the transport of the solids. That's all it is. It's diffusion. This hasn't gone anywhere. Why people believe that bullshit is just beyond me. Then they cite these 2 tests. Then when I read the tests, the 2 tests that they cited, which was by the Army Corps of Engineers in 1974-75, and the Brewer study in 1965 by the Portland Cement Association, they both came to the same conclusion. The moisture damaging the floor came from the surface, not from underneath. But we were all taught it came from underneath. And that has been taught, and that's why they have vapor barriers directly against the concrete. It's an idiotic idea. It has no basis in fact. It's all conjecture, all speculation, and no science. So if you wonder why I'm so angry about this stuff, now you know why. We've been told bullshit after bullshit after bullshit. None of that has been true. So if we start helping people with this factual information and just how simple it is to correct these issues, we can put a lot of attorneys out of business. So one of my goals is to walk into a McDonald's one of these days, see a former plaintiff attorney behind the counter saying, "May I take your order, sir?"
So Robert, here's a question. Maybe it's too far-fetched. Given E5, if we put E5 in our slab, can that or could that potentially eliminate the use of the vapor barrier?
Yes, I will say that.
Right?
I'll say, well, suppose you get cracks. Well, if you do the concrete properly, you won't get cracks. You cut your joints. If you do everything correctly, you don't get them. Especially with the E5 and with the surface catalyst, you're not going to get cracks. Not through cracks. You'll get maybe some surface cracks, but there's not through cracks. If you get a through crack, it's a subsidence crack. It's a structural issue. It has nothing to do whatsoever with what you do with your concrete. So I don't know why they keep mixing and matching these things.
So E5 with the catalyst, we could remove the vapor barrier?
Yes.
Opinion?
Absolutely.
And then for saw cuts, how far apart do you think the saw cuts could go?
I would still use the 1x2 rule. For every inch thickness, you cut your saw cuts 2x2. So if it's 4-inch thick slab, you cut it 8x8, 5-inch slab, 10x10, 6-inch slab, 12x12. But it is the timing and the cutting that's the most important. But that may not be the issue with E5, which is another curiosity I have. Is I'd love to see what the timing is for us for strain, because I think that E5 will be able to give you a better timing where you can come in on a harder slab with a little more time, and you can cut it to where it doesn't unravel, but you also cut it to where it hasn't hit restraint yet. Because again, it's not dehydrating the same way, it's not drying out the same way. So you're not getting that restraint that you normally get, because concrete restrains about a 1/2 inch every 100 lineal feet, which is, that's why it squares itself off like that. So if you ever want to really look smart to the client, walk in, if you see a crack pattern, start stepping it off. And I've done that time and time again for the last 40 years. And So how thick do you think concrete is? I'll step it off at 6 inches thick. So how do you know? It should cracks every 12 feet. No matter how it's cut, you just look at the cracks. The concrete will square itself off. And some people go, I want a rectangular one. Well, the concrete doesn't give a damn what you want. It'll crack where it's going to crack anyway.
Were you part of the discussion about the infinity slab?
No,
Anyway, the infinity slab, I think Robert's familiar with that. And Michael and I talked about it the other day, that with helix fibers, you can go 100 by 100 feet.
I have seen concrete like that. I've seen different ones where they've had nano particles in there and fibers. And the one slab I saw where they did that, they did have to have a slip sheet underneath it so it doesn't have any grab to the sub base. So if you wanted an infinity concrete, I would recommend putting a vapor barrier that acts like a slip sheet, not as a vapor barrier itself, but just as a slip sheet, just so the concrete's not being restrained from underneath.
Wouldn't the logic of being restrained have something to do with, like, if it doesn't shrink, then why would you need a slip sheet?
You can't depend on the concrete underneath shrinking and drying in the same manner. I would take that out of, but all you need is something as cheap as visqueen. You could use a 6 mil visqueen that costs almost nothing. Just spread it out and lay your concrete on it. But that's a good point. You may not need it. The only time I ever saw that is where I saw 100 by 100 feet with no cracks. They had a vapor barrier underneath. They use it as a slip sheet. But that's a good point. If you're not having a restraint, it may not be of any value. I hadn't thought about that.
Michael Mcleod was telling us about, there's fibers, steel, what are they called? Helix fibers. And then the founder of that company started another company, and he has something called twisted steel fibers.
No, it's called Steel X. They're both twisted steel fibers, but
It would make some sense for the precast industry to use fibers, wouldn't it? With an E5.
Yeah, I don't know what this does with the placement, the mixed design and all that. So I don't know. So I can't really comment on that. I would have to see those fibers in action. So I'd love to see it coming out of the chute, seeing how it's placed, how it's finished. Because if you have any of those things poking out, that could cause some issues, especially with floors. Because one of the things that makes me nervous about metal is metal changes temperature about 100 times faster than concrete. So if you have any areas that are exposed to heat, or say next to a window or someplace where there can be a transfer of heat, it could cause some issues. So I'd have to look at that as well.
You've got a lot of homework to do, Robert.
Oh. I walked right into that, didn't I?
Anyway, we could probably wrap up. Robert, it's been good. And thanks for your questions, David. Let's try to do some follow-up with the precast guy.
Yeah, that'd be a great start.
Yeah, I'll get a hold of him probably tomorrow and see what we can put together.
Okay. Just let us know when you're ready.
Okay.
Thank you, David.
Thank you.
Hey, Rick.
Robert.
He's an old buddy of mine.
David.
Rick and I met about 30 years ago.
Rick, do you have any more questions? I know you and Robert have been working on a few things together, and you were going to go off and do some more testing, but I guess you're still proceeding on that project. What was it, the gymnasium?
Correct, we are.
Yeah, he's got some
Just waiting
interest
for the purchase order. But the one we're talking about, Robert, is I found the concrete to be healthy with the testing, and you're suggesting there could be some contaminants because the salts are coming from the salts in the concrete are swelling and robbing or whatever the procedure you said to me about giving us a false negative about what the readings would be.
Exactly.
So
Because all salts will steal moisture, especially.
So what's happening is I haven't gone and done the test with the Trimax because they want to know ultimately what the next step past that is. And I'm saying, well, it sounds like we're going to have to do some kind of short core analysis in order to.
Now, if you did the Tramex test and it's over 5%, they've got an issue. Now we have a starting point.
Okay, well, I'll still push that, but I
Well,
guess
when
their big concern now is this concrete rotten, and what do they got to do with it? Because it's in a finished state. They got carpet walls up, and
There are other options, and some of them, where they may have to put in a sleeper system. There's also some that I forgot the name of it. It's like a corrugated these sheets that you can put on, basically gives an air gap with between the concrete and floor, and it'll give you a nice, hard, strong floor. So I think it's a German company, and I can't remember the name of it. I think it begins with a D or something, but I haven't dealt with them.
I was talking with a chap when I had to break away, and he had mentioned something about a product called DMX floor underlayment. It's kind of bubbled on one side to allow moisture to kind of break through as a sleeper system, and then put the carpet over there. I said, don't jump into that yet. Let's find out what's going on first.
Yeah, I like air gaps, because if you don't leave air there, you're going to get mold.
Correct. That's what I said to him. You know, he's gonna have a
Yeah,
problem.
no, I don't like anything hugging. I don't like a vapor barrier directly over the concrete. I just don't like that. Just not a good idea.
I'll get it with the Trimax, and I'll email you the results, and then we're going to
Okay.
be sending off some short cord to a material handling company that will identify the problem,
Okay,
or whatever it is anyways, and I'll give you that info and seek your advice from there.
okay. Yeah, because that job may be a really good, I can see a future article with that one.
You
And,
mentioned that, Tony, so I'll give you as
Yeah.
much as I can so you can write your article, and refer to what happened up in Ontario.
Absolutely. Well, I mean, now I want names of all the players and everything else, because that'll be a good one. Real challenge. I kind of like those.
The other one we have, we're just waiting for the purchase order. It's 17 pounds on average in the slab. We're going to build a sleeper system. So I wanted to talk to you about, I don't know if this E5 is going to reduce the moisture below compliance level to take hardwood, because it's so high, because there's no written data on that yet, that's occurred with the E5 shield. So I may be stepping out of line here, but what about your SINAK, your Vectra R?
Because I'm not involved with my old company anymore, I hate to say this, but I don't trust what they do. Because
Okay.
one of the reasons why I left is the wrong product was shipped to Mapei. And I told them they need to call them, let them know. And they fought me on it, said, no, just let it go. I said, you sent the wrong product. Tell them you made a mistake. We have to reset the testing dates and everything else. And they refused to do that. I got outvoted. And I said, you don't think for one moment they're not going to analyze what you sent them? I said, no, they're not going to do that. Well, that's exactly what they did. And then basically they ruined their reputation with Mapei. And they also ruined their reputation with me. I said, I want nothing more to do with you. I want you to buy me out and I'm out of here. That's
Okay,
why
good
I'm
information. Again, it's, I'm all hip on this E5, but with the pounds up where they are, I'm just a little,
This may be a multiple. What the best thing to do is put something in the concrete to slow it down. Then we can put something on the concrete to keep slowing it down, because Ardex and Mapei both have some fairly good products that are polymer modified that you can put down that give it a little bit more of a slowdown. And then where they could finally put a membrane over the top of it, then put the wood floor down. Because what you don't want is you don't want an absolute line of demarcation where you don't give the moisture and possibly some of the chemical reactions someplace to go. So if you have a trowel down system, I've seen the difference where they put down an epoxy, and the only place the epoxy failed is where they didn't put down the Ardex. Where they put down the Ardex, it wasn't failing because it gave it somewhere to go. So I think if we use a multiple approach like that, I see no reason in the world why they can't put the hardwood down.
okay, so we're just
Just don't
waiting
be
for the PO.
over-dependent
So
on
you're
it.
thinking spray it anyways with the shield? Is that
Yes.
what you're thinking? Okay,
Yeah,
and
to
then,
start, densify the concrete, tighten it up, give it a better base for something else to put down on, just keep slowing it down, a trowel down.
Ardex has their MC Rapid. Are we jumping to conclusions to go to that, or?
No, I don't think so. I think it's a good idea.
Okay, well, I'll be in touch with you on that one too.
Yeah, because Ardex has some good products, right, gentlemen?
It would be interesting to try the shield, Rick.
I'm sorry?
It would be interesting to try the shield in that situation.
Well, I think, Mark, what's gonna happen is we're just waiting for the purchase order, and then we're gonna go in and we're gonna grind the floor, because there's adhesive on it, very thick adhesive on it right now. We're gonna grind it all off and open it up. What I wanted to do was contact you, and I want to do a test area, 100, 200 square feet, and just see what kind of reading we'd be getting on the after fact.
Yeah, that's a great idea. Again, use the Trimex and then
How many square
now,
feet, Rick?
I'm sorry?
How many square feet?
8,000 square feet on the one we're talking right now.
3,000.
Okay, there's 8,000 square feet on the
Oh, yeah,
square
right.
feet in the project, but about 100 or 200 square feet test. do, you know, like Robert was saying, put the Trimax down on the, after it's ground off, and then use the the shield, and then do it again and see where we are. See
And
where
then
it's
you
done.
do that each stage till you bring it down to where it's tolerable for the hardwood. Then nobody's guessing. You've taken all the guesswork out.
Right. So they're thinking of putting a sleeper system, and we're trying to talk them into, no, you can if you want, but why don't we use like MC Rapid and then put a leveler over top of that? You know,
Because
and then
if the shield doesn't work, then you go with a sleeper system. Then you go with a trowel down, epoxy sleeper system, then put your hardwood.
yes.
But that's
So
really
that's gonna be in the
expensive.
next week or so, Martin. I'll
Okay.
be in touch. Keep everybody posted on that one.
Sure, Rick, we can meet for lunch and try a pail.
Yep, absolutely.
Righty.
And Robert, I'll get back to you about the ugly one contamination.
Okay.
very soon.
Okay. All right.
All right. You have a good day.
You too. All right, guys. Is that it?
Now, Mike, you're done asking questions? You're good?
Yeah, I'm good. Thank you.
Thanks again, Robert.
All right. Thank you, gentlemen.
Thanks, guys.